Hello everybody. Today we are going to learn electronic displacement effect. So organic compounds, those have the compounds of carbon where different atoms are held together through covalent bonds. The movements of electrons can have its orientation in any direction. So that has a greater impact on the reactivity of the molecule. So there are different ways through which the electrons will displace in a molecule. So the number one is inductive effect and electromeric effect. Third one is a resonance or a mesomeric effect. So mesomeric effect is also called as resonance effect. The fourth one is hyperconjugation effect. Now let us see about these effects one by one. So the first one is inductive effect. So inductive effect is induced effect. So how it is arised is, so consider a hydrocarbon which has carbon and hydrogen atom. So if you look at carbon and hydrogen atom, they don't much differ in their electronegativity. Hence they form sigma bond by sharing of electron. So if you replace any one of the hydrogen atom by some other atom, say for example if you replace it by fluorine atom, which is more electronegative compared to carbon atom. So electronegativity, due to its higher electronegativity, it pulls the electron towards itself. Hence it becomes negatively charged, whereas the carbon atom becomes positively charged. This carbon now attracts the electron from the next carbon atom. So similarly, if you consider the replacement of hydrogen by some other atom, here let us consider the lithium atom, which is more electropositive compared to carbon atom. Due to the electropositive nature of this lithium atom, it easily gives away its electron. Hence carbon gets the electron through this sigma bond. So now lithium carries positive charge, carbon carries the negative charge. So this induces a small negative charge on the adjacent carbon atom. So the carbon which is attached to this carbon atom. So this is called as inductive effect. So if in the case of fluorine, it is called as minus effect. In the case of lithium case, it is called as plus effect. So this effect operates through the sigma bond, and you should also note down that it is extended till gamma carbon atom. So it will not be operating beyond this carbon atom. So it will not operate in fourth carbon atoms. So this is about inductive effect. So the next one is electromeric effect. So electromeric effect is a temporary effect. It is observed in multiple bonded compound. So when any reagent, for example polar reagent, approaches this double bonded compound, then the pi electron will be moved to any one of the carbon atom depending upon the substituent present in either side of the carbon atom. So now it is undergoing displacement and creates this type of charge separation. For example, in the case of carbonyl also this is observed. So this is called as electromeric effect. So this is a temporary effect and it arises due to the approach of reagent. So now let us move on to the next effect, that is called as mesomeric effect. Mesomeric effect is also called as resonance effect. So this is observed in the pi system, which has mostly conjugated double bond. If conjugated double bond is present in your molecule, there will be possibility of having resonance effect. So it is a permanent effect. This involves the delocalization of pi electron in a system. So let us consider this 1,3-butadiene. So the displacement of electron happens like this. Due to this displacement, the charge separation occurs. So it develops CH2 plus here and minus here. So this undergo a resonance. So sometimes this carbon will carry negative charge and this carbon will carry positive charge. Overall, the resonance hybrid can be written like this. So this is called as resonance effect. So this is mostly observed in conjugated pi system. Conjugated means alternatively double and single bond is present, means then we can expect this kind of resonance effect. Sometimes the double bonded carbon will be attached to carbon. If that carbon is attached to a heteroatom like oxygen, nitrogen, which has a lone pair in it, then that lone pair will be involved in resonance. So then also we can expect this kind of resonance effect or mesomeric effect. So this is also called as plus R effect and minus R effect, or sometimes it is called as minus M effect plus M effect. For example, in an aromatic compound, if nitro group is present, nitro group is electron withdrawing group. So it pulls the electron towards itself. So it pulls the electron from the ring and causes this kind of displacement. This is called as minus R effect. So sometimes if the group or an atom that is present in the aromatic ring, if it has lone pair in it, then the lone pair will be transferred to the ring. So the electron displacement can occur as shown here. So in that case, this is called as plus R or plus M effect. It occurs due to delocalization of pi electron. So the fourth one is hyperconjugation effect. In the resonance effect, the delocalization of electron occurs through pi overlap, is it not? So the pi electrons were involved in delocalization. But in the case of hyperconjugation effect, delocalization of sigma electrons through sigma pi overlap occurs. That is, sigma electron is involved in a resonance here. See, for example, in the case of propylene, so the double bond is not conjugated actually, but it is attached to the carbon, which is attached to a CH3 group, and this CH bond, the sigma bond, that involves in resonance. So this sigma bond is moved to this position and that displaces the pi bond like this. So due to this, we can get so many resonating structure. If there is more number of resonating structure, then the compound is said to be more stable. So this is also one kind of permanent effect, but it arises due to the sigma electrons. So sigma bond is involved in resonance. So due to this resonance, there is no bond between carbon and hydrogen. Hence it is also called as no bond resonance. So this is about hyperconjugation effect. So due to this, you should also know here that due to this hyperconjugation effect, propylene, we say propylene as stable compared to ethylene. So we don't expect any hyperconjugation effect in the case of ethylene case. So propylene is most stable compared to ethylene due to hyperconjugation effect. So with this information, I'll close this session. So let us meet in another session later on. Thank you all.